Welcome to the Data Structures and Algorithms series. This is the first video in the series, which will be a quick dive in to what data structures and algorithms are before we delve in much further. To quickly go over the data structures and algorithms definitions, the data structures are basically structured means of allowing a computer to efficiently access data. On the other hand, with algorithms, to generally define it, it's a set of instructions that help achieve a particular objective. To get more specific, when you see the term DSA in coding prep or some other situation, is basically a set of instructions that help implement particular search mechanisms. Some common data structures used in interviews and the industry, they are queues, stacks, linked lists, binary search trees, graphs, and hash tables. So to go over the first data structure from the list, the queue. The queue is a first in first out data structure that incorporates data in a sequential fashion. The very first element of data that is in the queue is the one that ultimately moves out. So there's an example stated over there. And from everyday examples, there's a lot that resemble the queue behavior. So below, there's 1, 2, 3, 4 in the before, and after 1 has been removed, there's 2, 3, 4 only, because 1 was done with its job. With the queue structure out of the way, now the stack. The stack is a last in first out data structure that incorporates data in a sequential fashion again. So that's where it's similar to the queue. But the last element that has come in moves out. So a dining plate stack at home or at the restaurant is something that can be thought of. Below, there's the before with the EDCBA all stacked from down to up. And in the after, the A has been removed because it was the topmost element in the stack. To go into linked list, a linked list is a data structure that consists of nodes filled with specific values and are connected by pointers, and it follows a sequence. There's a header node, in between nodes, and a tail node. The pointers serve as the memory address for finding a particular node of interest, and memory address is a little bit more on the hardware side and will be explained in a future video. With the sequential style data structures covered, let's go into the binary search tree. A binary search tree is a tree-style data structure that consists of a root node followed by left and right children nodes. So in the figure below, the topmost node is the root node, and then there's a left and right children. All the left and right children nodes also have children nodes too. So the behavior repeats in successive levels and generations. A graph data structure is basically a node-based data structure that is connected by nodes and edges. They can either be directed or undirected, as seen below. So on the left one, there's no arrow pointing right or left, so it's undirected. On the right side, there's an arrow pointing to the right and arrow coming down. So these two respectively are undirected and directed graphs. Now finally, the hash table. A hash table is an indexing data structure whereby the value storage is dependent on the size of the hash table and can be resized if too many duplications potentially take place. So a couple of points mentioned on the right here are the hash function, whereby the input value followed by the modulo operator and table size provides the key. And the key is essential to storing the value. So you'll hear about key value pairs when you work with dictionaries, hash tables, and hash maps. And the value is stored in the particular slot, as seen in the example provided there. 20, 21, 22, all stored after the hash function operations. Algorithms will be covered in the next video.